Okay. Ladies and gentlemen, I'm happy to have the chance to talk to you about the permaweb and the SAP. These two ideas may still unknown to many, but they are quite important for future development of blockchain apps. Let's take a quick dive into these ideas, and understand how they impact the blockchain evolution. Before we talk more about the permaweb and the SCP, let's first take a look at what Trilemma is within the blockchain. The idea goes around the three core requirements: decentralization, security, and scalability. We all know there is a fragile balance with the three requirements. If a blockchain is highly decentralized, it's most like a sacrifice scalability. Secondly, going for high scalability often poses security problems. There is what known as the blockchain trilemma. We have seen over the past years blockchain projects struggle to balance these three aspects. So, can we improve it? Maybe let's get into how we have found a solution to this. First off, what is SAP? SAP is simple. It's a storage-based consensus paradigm with its core idea being that as long as storage is immutable and the transactions are traceable, then computing apps will result in the same end goal. This means that we will be able to achieve consensus without need of distributed computing. Pretty powerful concept, if you ask me. Let's take Arweave as an example. We may think of it essentially as a payment gateway, kind of like a PayPal. This is a big different role. Arweave transaction records are permanently stored on Arweave. This means everyone that wish to compute and verify Arweave the state can do so. A unique feature with a high level of trustlessness, something that PayPal doesn't have. The permaweb is entirely new web architecture, composed of three core components: application layers, service layers, and the storage layers. Unlike Web2 architecture, the permaweb storage layer uses blockchain tech to be more specific. It uses Arweave. What does Arweave bring to permaweb? Immutability and traceability. Security is ensured with the underlying storage layer. Decentralization is achieved with standardized protocols and open service layer. Service providers can horizontally scale and inflate the number of standardized service. Apps can flexibly utilize this standard service, solving scalability issues. The permaweb service layers include four protocols: gateways, bundling, sequencing, and indexing. What do they do? Gateways provide a static file service like Arweave.net or ARCD9 nodes. Bundling offers data bundling upload service like a bundler or ARCD9 node. Sequencer provider serialization for smart countries or financial service like web or Arweave. Indexing offers data indexing for Arweave, like the GraphQL or KN3. Devs can use any of these services to build perma-web service. Perma-web apps. Service provider can scale an infinite number of standardized services, which effectively solve scalability problems. Combining the SAP theory, the module allows the perma-web to provide a real-world solution to the blockchain trilemma I talked about. The SAP theory isn't only limited to the perma-web. We can integrate this theory with the microservice concept. This means that the storage layer can be more open, even use public chains like Ethereum as an asset service layer. Modular thinking will bring more possibility for future blockchain apps. All existing blockchains still struggle to achieve true scalability, largely due to the above trilemma I spoke of. I believe that SAP and the perma-web can create a new path. This path is based on a solid theoretical foundation validated through engineering practices. I look forward to the development of the perma-web as well as widespread of the SAP theory in the blockchain world. A big thank you for everyone that joined us today. Thank you for your attention.